Hello everyone, welcome back to today's class. Today we are learning gravitation, class 9. So in gravitation chapter we have finished and we have learned up to the free fall, and in up to this part we have learned about the capital G, means we have learned about the force that comes from the universal law of gravitation, and the force is given by capital G into capital M into M by d square, where G is the universal gravitational constant, capital M is the mass of the bigger body and small m is the mass of the smaller body, and divided by d square, where d square is the square of the distance between them. And after that we learned free fall, and in free fall we learned about the value of small g, acceleration due to gravity, which is 9.8 meter per second square. Today we will move on to our next topic, that is mass and weight. So mass and weight, these are the another topics of this chapter, and first we have to know about the difference between the mass and weight of an object. Mass is the measure of inertia of a body, and weight is the product of mass and the acceleration due to gravity acting on an object. So mass, it is the measure of inertia. Measure of inertia is actually measuring the state of an object, whether the object is moving or not. In that position or in that state, we measure the mass of an object. And weight is the product of mass and acceleration due to gravity. So W is equal to M into G, mass into the gravity. So simply we can understand like weight comes due to the gravity. Like for example, if there is an object which has been placed on a scale, on a balance, if we are measuring any object on a balance, what we do, we place the object onto the balance, and on the balance there comes the weight. That means there comes, first of all, there will be the mass of the object. Any object will have a certain mass, and since the object is on the earth, the gravity is acting on the object. So the gravity will also be acting here downwards, and totally, finally we get the product of mass and the gravity, which is termed as weight. So weight can be also understood or can be also expressed as the force acting on an object due to the Earth's gravity. So from here we can say mass is always, mass does not changes. Mass does not changes. For example, I have this chalk. Just assume that this chalk has a mass of 10 grams, for example. Then this 10 grams, this mass of the object or mass of this chalk will never change or will not change if it is measured on this place or measured in some other place. But the weight can change, because weight is directly proportional to mass and proportional to gravity. That means weight is equal to mass into gravity. So if the mass changes, sometimes if it is m, sometimes if it is some other values of m, then the weight will also change for the body, and also it depends on the gravity. Like for example, I told you previously the value of g is small g, acceleration due to gravity sometimes can fluctuate. Basically it is 9.8, but in some places it can be more than 9.8 or sometimes it can be less than 9.8. So if the value of g changes, then the weight will also change, and the value of g also changes for different places. Means basically we are talking, if we are talking about planets, if we are talking about our moon, if we are talking about the earth, then on the moon the value of small g will be different, and on the earth the value of small g will be different. So accordingly the weight of the object will also change on our earth or on our moon. So number 2 here, weight can change with respect to the position or location of the object. So next you can write it down. So this one you can use as a difference between mass and weight. And next we are moving on to the next topic, that is weight of an object on the moon. Weight of an object on the moon. Now just before some moment ago I was saying that weight can change. So weight basically depends on the mass and the gravity, means acceleration due to gravity acting on the object. So if the object is in some other area apart from our earth, then the weight will also change because of the acceleration due to gravity of that area. Like for example, in our earth the value of small g is 9.8, but on the moon the value of small g can be different, it will be less. So as the radius or as the size of the moon is much smaller as compared to the earth, so does the gravity of the moon will also be less than our earth. So what happens in this event, the weight of the object will be different on our earth and it will be different on the moon. Means weight of the same object will differ in both the cases. So in your book in page number 137, in right hand side there the weight of an object on the moon is calculated, where the formula used is W G M by R square. So this is our only our gravitational formula, F equal to G M by V square. This is just our gravitational formula, only instead of force it is taken as a weight, and the d square is taken as the radius or the distance between the earth and the moon. And here in this case, since we are finding the weight of an object on the moon, so here it is taken the radius of the moon. And here this is the capital M is the radius or mass of the moon. This is because our earth somewhere here our moon. So what happens if I am measuring something on the moon and measuring something on the moon, then accordingly I will take the distance between the object and the center of the moon and the mass of the moon. So the radius of the moon will be taken and the mass of the moon will be taken. And solving this and putting the values, the given values which are there in the book, page number 137, table 10.1, the mass of the moon is given 7.36 into 10 to the power 22 kg, and the radius of the moon is given 1.74 into 10 to the power 6. Using these values, it is solved and the weight of the moon to the weight of the earth. Means using these values, we will take the value of g if we are just solving as per the book, weight of the moon, sorry, mass of the moon, that is 1.74 into 10 to the power 6 kg into the mass of the object, which we don't need now, which we will take the ratio, and the radius of the moon, that is 1.7. Okay, my mistake while writing. This is 7.36. Then 1.74. 6, and this was 10 to the power 22 kg. And after solving this, we get the weight of the moon, which is there in the book, and then it is taken the ratio of the weight of the moon to the weight of the earth, where the ratio comes as weight of the moon by weight of the earth, the ratio comes as 1/6. That means the weight of the moon is 6 times less than the earth. So accordingly, the gravitational force, or we can say like acceleration due to gravity on the moon, small g value on the moon, will be 6 times smaller than the earth, and so the weight of the moon is, the weight of an object on the moon will come as 6 times less than our earth. So if any object on the earth is 60 kg, that object on the moon will weigh only 10 kgs. And similarly, if an object is 60 kgs on the moon, the same object will be weighted 360 kg on our earth. So this is the ratio of weight of an object between earth and moon, 1/6. So this much is required in your syllabus in this year. And in this part, in this chapter, the up to mass and weight will be required. And the upcoming, the next topics, thrust and pressure in fluids, buoyancy, Archimedes principle, and relative density are not required for this year 20 to 21. So thank you. Only this for today.